Okay, we've got one more family to go that we need to know for Chem 30, and that's the esters. It's similar to the carboxylic acids, or at least it's really closely related to it, but it has some differences that we'll go into. So the first thing you need to know is that an ester functional group is a little bit different than a carboxylic acid functional group. That it comes, instead of being on the end like the carboxylic acid COOH is, it's in the center, or at least in the middle somewhere of the molecule. So the common notation for this would look something like R, remember, which stands for the rest of the molecule, and then that would be connected to a carbon, double bonded to an O, and then single bonded to another O, not an OH. So if this was a carboxylic acid, that would be an OH. And then coming off of that would be, we call it sometimes R1, or it's basically the other half. There's more carbon coming off of that side. So we would have carbons over here branching off, and we would have carbons potentially over here branching off as well. And then this group in the center is what we call an ester linkage, is the name of that functional group, because it's linking the two molecules together. Now the reason I've used two different colors here is because in an ester it comes from two different molecules. So in this case, an ester is made by combining a carboxylic acid, which in this case I've shown using blue, and over here the other part of it comes from an alcohol. And that combination, the reaction between those two, is what creates the ester. We'll learn more about the specifics of the reaction later, but for now you need to know that this side right here is from the carboxylic acid, and then everything over here comes from the alcohol. If you have trouble with that, one thing that I sometimes tell students to look for is where are the O's pointing. And so you can see the O's here are attached to that carbon, meaning that this one is going to be the parent. So in this case, the carboxylic acid is the parent. So the O's are helping us see that they're focused on that carbon. That's our parent carbon chain, which means that the other carbon chain coming off of it is going to be the branch. Okay, now this is starting to look really messy here, so we'll clear this up, and hopefully it'll make a little bit more sense for you when you see a couple of examples here. So let me pause for a second and just fill this in. All right, so here's a molecule, the first example in your notes. And the first thing you have to do, just like with all organic molecules, is find the parent. Remember that in this case, the parent is the longest carbon chain, not the longest carbon chain, but whatever carbon chain the O's are pointing at. So it doesn't matter even if it's the shortest carbon chain. So if we look, the oxygens are pointing to that carbon, which means that this is my parent chain, and this over here is going to be my branch chain. And we also have our ester linkage that's connecting the two together. Now, in order to write out our name, it's very similar to the convention we've been using so far. So we have a 2-carbon branch, so that's an ethyl. And if we would have named the parent before, it would have been a 3-carbon, which is a prop. And we would have called it a propanoic acid. Remember, the parent comes from a carboxylic acid. But in this case, we're going to drop the oic acid. And because it's an ester, we add on the end O8. So this is ethyl for the branch, propan for the parent, O8 because it's got the ester linkage connecting those two pieces together. And that's as complicated as it's going to get for these ones. They don't end up with extra branching in Chem 30 or anything else that you need to worry about. You just need to be able to identify the parent, the branch, and the fact that there's an ester linkage. Now, the naming doesn't get more complicated, but they will expect, at least later on, you to be able to look at this molecule and tell me what carboxylic acid and what alcohol combined to make this. So if you remember that the branch had to have come from an alcohol, that had to have been a 2-carbon branch with an OH attached to it. In fact, this O right here is actually the O from that alcohol group. The H is going to come off. Again, we'll learn more about that later. But that O is where that came from. So this would have had to have been an ethanol molecule that was here. As they get bigger, like let's say a propane, you'd have to say propan-1-ol or butan-1-ol or any of those larger ones to show where that alcohol group was. And looking on the other side, we have a 3-carbon carboxylic acid. So that would have been a propanoic acid. So the reaction to make this would have been propanoic acid and ethanol combined. So sometimes the question will show you the molecule and ask you what carboxylic acid and what alcohol were used. Sometimes they'll give you the carboxylic acid and the alcohol, and you have to draw the the ester. Sorry. All right. Let me pause here and draw the next example. Okay, here's our next one, and this one's drawn in line diagram. Doesn't change any of our steps. We just need to be careful to make sure that we're familiar with our line diagram rules. So remember that the parent in an ester is not the longest chain. It's whichever one the oxygens are pointing at. It's the carboxylic acid parent. So you'll see right here that they're pointing at this carbon right here, which is just a single carbon. So even though it's only 1 carbon, it's still the parent. And this longer chain over here of 2 carbons is a branch. And of course, this carbon double bonded to an O and single bonded to another O, like that, is our ester linkage. So if we were to name this, we would start with our branch. It's an ethyl. Our parent molecule is a methan, and it would have been methanoic acid, but now because it's an ester, it's going to end in O8. So ethyl methanoate for this one. This one's a little tricky because it's a expanded molecular. It's not drawn out in condensed or structural or even line for us. So, but we can, if you're familiar with expanded molecular, you'll remember that the molecules are still kind of grouped together. So we see our first CH3, then a CH2, and another CH2. The ester group on something like this, just like on acetic acid, the carboxylic acid is a COOH. In this case, the ester linkage is this COO. And the things that are attached to the carbons always follow it. Like these 3 H's are attached to that carbon. So these 2 O's are attached to this carbon on the left, which means that this string of carbons is the parent, and the other string of carbons is the branch. I guess I should have drawn that. Circle that in green if I'm keeping with our color scheme here. The branch would have been this string of carbons, and the COO would be the clue, the evidence that would tell me that this is an ester. So we still start with the name of our branch. So this is a, whoops, not red, propyl. And then we have a butan, 4 carbons on the parent, and it's an ester, so it's O8. So propyl butanoate. All right, hopefully that all makes sense to you. The last part is looking at their physical properties. So the boiling points of these guys, because they have this ester linkage group here, it does make the molecule slightly polar, or it's polar, but it's not like alcohol polar, right? There's no hydrogen bonding involved here because the O's aren't attached to an H. So if you were to compare an ester to a carboxylic acid that had the same amount of carbons between the two of them, the carboxylic acid would still have the higher boiling point. The alcohol with a similar carbon content would still have a higher boiling point than these ones. And the bigger the chains get, the less soluble they get. So small ones are fairly soluble, but the bigger they get much, much less soluble. Common esters, there's no specific ones you need to know, but you should know that animal and vegetable fats are common esters. So when you're talking about maybe in biology, triglycerides or fatty acids, things like that, those are esters that are holding those molecules together. And some of them are some of these have a distinctive odor. So sometimes they're used in making synthetic additives for candles or for perfumes or things like that, because you can manufacture the particular odor that you're looking for. Okay, that's pretty much it for the esters. If you have any questions or any trouble with any of this, don't hesitate to ask. And otherwise, that's it for all the nomenclature stuff that we need to know. So if you have any questions on anything leading up to here, make sure you reach out. Otherwise, that's the end of the first section for this unit. So catch you on the next one.